So welcome everybody to this webinar, or welcome back for those who have followed the previous webinar. So I am Mathieu, an application chemist at ThalesNano, and today's topic is the gas module and how you can use it to extend the scope of your reactions, of your flow reaction, by introducing gaseous reagents. So let's go through the plan of this presentation first. I'll first give you a short introduction and then a quick reminder of the continuous flow chemistry. We will then go to the feature of the gas module and the advantage of combining it with the h-cube, for example, or extensively even with the Phoenix flow reactor. So I will then show you some examples of the chemistry performed by giving details about some reactions and results that has been done on those instruments. And I will finish by showing you the setup in a real laboratory environment before answering your questions. So please, during all the presentation of this webinar, feel free to send us your questions. So, I'd like to give you a recap of the previous episodes. So, we talked about the h-cube mini plus, which was the very first webinar we did, and then the h-cube pro, the big brother of the h-cube mini plus, I would say. We had one on the photocube, on the CAD cards also. CAD cards we showed you the different cartridges that can be used with our instruments and the catalyst. And the last one was about the h-genie platform, so the scale-up combination, I would say. So if you want to watch them, please go on this link and you can register and check them out. So a few words about ThalesNano first. We are making laboratory reactors that chemists and chemical engineers can use to create new drugs, new aromas, new chemicals, or even new processes. So you can see here some important figures and a picture of the h-cube pro, which was one of the winner of the R&D Top 100 Awards along the h-genie. So let's have a quick look at our portfolio. So we have a wide range of instruments for all kinds of needs that can perform them different kind of chemistry. So for really exothermic reactions, for example, ozonolysis, so on, we have the ice cube, which can go down to -70 degrees. Then on the other side of the spectrum, we have the Phoenix flow reactor and the flash pyrolysis platform, which can go up to 1000 degrees Celsius. So you can see here the gas module, so what we are going to talk about today. And here it is in a combination with the h-cube, so the same setup we are talking about today. So you can also here see the h-genie with the Phoenix flow reactor, the scale-up combination, and then I would say our last product, or lastly born product, the photocube to do photochemistry reaction. Okay, so a quick reminder about the flow chemistry first. If you want more detailed about it, please refer to the second webinar, to all the webinar, but mostly the one about the h-cube pro, where we give like a quite thorough description of what is flow chemistry. But I would like to give you like I would say, a short and simplified definition to, I hope, help you better picturing it. So it could be seen as a moving mixtures of materials and solvent for an ongoing, continuous synthesis. So it is at the very least a pump and a reactor, but it can be much more complex. It can have like several pumps, several reactors, mixers, back pressure regulator if you want to build pressure inside your flow system, mass flow controllers if you'd like to inject gases into your system, and you can even have an automation to control all of this flow system, and even a built-in analytical tool if you'd like to monitor your reaction, your continuous reaction in real time. So eventually it is three important parameters. So a residence time, which is basically the reaction time, a temperature and a pressure control. Those are the physical parameters you can play with and fine-tune in order to get better yield and selectivity of your reaction. So let's talk about the gas module now. So you can inject gases from 25 to 140 bars. So I mean in the cylinder, in the external source of gas. And then it can deliver to your system up to 100 bars. So the flow rate you can use is between 0 and 100 normal milliliter per minute. So this is a mass flow controller you can control directly used for the gases in a continuous flow environment. So it's pre-programmed with 14 gases. So you can see here the list of those gases. So oxygen, carbon monoxide, dioxide, ethylene, syngases, for example, to do hydroformylation, methane, helium, hydrogen, nitrogen, and so on. It is versatile as it is compatible not only with the HQ Pro but the Phoenix flow reactor, or like on its own, like I mean with any other flow system. It is easy to use, robust, and reliable. So now the gas module works seamlessly with the HQ Pro, allowing like the 14 gases to be used at up to 100 bars. With the same touch screen device you would use with the HQ Pro alone. So reactions such as carbonylation or oxidation can now be performed with the HQ Pro at the same high pressure and same high temperature, so up to 150 degrees with the HQ. So HQ Pro gas module combination provides you a safer reaction due to the small volume in a given time. So this is a characteristic actually inherent to flow chemistry. Still, there's no catalyst handlings as in the HQ Pro alone, an improved heat transfer and mixing, a better selectivity because of the low residence time mainly, fast reaction, so from seconds to minutes. If you compare it to batch, it can go up to hours of reaction, even days in some cases, and a wider range of reaction thanks to the gas liquid solid interaction, and easy catalyst handling. So this catalyst handling is really easy thanks to the CAD technology, which makes the catalyst remains in the CAD after the reaction. So another advantage and a green advantage is using gaseous reagents over chemicals reduces the workup and purification time. So let's talk about chemistry now, and I'm going to give you a few examples. So even though the H-cube alone could provide you the hydrogen, nothing stops you to use the gas module to inject an external source of hydrogen. So in this study it was done. So a series of commercially available catalysts were studied for the hydrogenation of limonene under mild reaction conditions. So from the comparison of those catalysts done under batch conditions, so the screening was done under batch, so the platinum and ruthenium based catalyst showed highest selectivity towards the P1 methane as compared as the palladium based catalyst. So in particular, the platinum on charcoal and platinum on alumina showed an excellent selectivity. So even at high substrate conversion, so more than 90%. So kinetic studies showed that platinum on charcoal can differentiate between the terminal and between the internal double bonds. So in limonene, under those mild reaction conditions. So the stability of platinum on charcoal under those conditions allowed for the hydrogenation of limonene with almost a quantitative conversion, so 96%, and a P1 methane selectivity more than 87% that was maintained for at least 5 hours on stream. So now let's talk about oxidation. So here 0.1 molar of anise alcohol was used in acetic acid, and it was used to selectively oxidize to the corresponding aldehyde using an oxygen gas and a card filled with gold and titanium oxide catalyst. And the best conversion here was found at a temperature of 102 degrees, 47 bars, and 0.9 milliliter per minute. So it is also worth saying that those conditions, those reaction parameters for the optimization were determined by a simplex algorithm. So it is an algorithm built in the H-cube Pro. So it's another feature of the H-cube Pro, regardless it is combined with the gas module or used as a stand-alone. So now for the second example of oxidation, the oxidation of ethanol. So an improved selectivity compared to the batch synthesis could be achieved here at 150 degrees and 10 bars, and reaching a conversion of 97%. Nevertheless, the highest selectivity of 65% has been achieved at 175 degrees. But if you compare it to batch, in batch it's 45%, so it's 20% more than you would get in batch mode. Okay, I said here I put the diagram, the flow diagram, and you can see so the cylinder and then the gas module here. So the flow line here with the mixer and the Phoenix flow reactor is used here before the back pressure regulator and collecting your product. So now in this example, they use the gas module to inject oxygen for cleavage of different olefins. So they demonstrated the palladium catalyzed oxidation of olefins into the carbonyl compounds. So low catalyst loadings, 0.1 molar here, provided moderate to excellent product yields in a short reaction time, so 25 minutes reaction time, residence time, sorry. So major advantage of the flow protocol actually is the ability to handle pure oxygen under a process intensified condition, so in a safe and scalable manner. So here again I put the flow setup. You can see the oxygen cylinder, the MFC, so this is where the gas module is. So the Capet group performed here a lithiation followed by a carboxylation of different heterocycles and alkynes. So the gas module was used here to inject CO2 gas to the organolithium intermediate. So with this method, they synthesize a carboxylic acid within a reaction time of 3.5 seconds. So using a low excess of organometallic base and a gaseous reagents to give a moderate to good isolated yield. As you can see, it's between 40 and 80% here. So again, the diagram here shows you the different liquid line here and the gas line here, where the gas module is used to inject CO2 here. Okay, the Capet group again here, this time they decided to combine a Phoenix flow reactor, not a HQ, but a Phoenix flow reactor with the gas module and a carbon monoxide cylinder. So they studied here the carbonylation of aryl chlorides using CO gas under high temperature and high pressure conditions. And among all the catalytic systems studied, so the palladium acetate provided the best performance due to its high stability under those high conditions, so high temperature and high pressure. So the flow protocols here use 5 molar catalyst loading. So although the loading is higher than in some batch conditions, the reaction time is significantly reduced to only 16 minutes in flow compared to a longer reaction time necessary under the typical batch conditions. So an advantage is in contrast to operation within batch. Here there is no vapor phase or head space in this flow system because all the gas was dissolved in solution, and since a very low amount of carbon monoxide, 2 to 3 equivalent only, has been used, it improved the safety and potential scalability of this synthesis. So here again you can see the setup. So the carbon monoxide cylinder with, you can get the gas module here. So you have the liquid line and a mixer, and after the mixer you have the Phoenix flow reactor which was put here before the back pressure regulator and the collection of product at the end. So this last example is more for, I would say, the beauty of the synthesis, as it is actually not a proper multi-step synthesis. I mean by that although the steps are subsequent, they are not in the same continuous flow. But still, I would like to show you here the possibilities to synthesize more phenolids and derivatives and performed, if not all, at least a part of the full synthesis in continuous flow. So the gas module has been used here independently from the H2Pro in the first step here to inject oxygen for this N-demethylation step. So the mechanism is actually pretty interesting, as I will let you go and check into the article, but the acetyl group here is going to come here, displacing the N-methyl group. So a conversion of 96 to 97% has been achieved here. So okay, so this first step was done using the gas module to inject the oxygen here. So now the subsequent step involved H2Pro. So they took the same mixture, and so with the H2Pro in hydrogen mode and with less than 1 molar of palladium and alumina catalyst, they managed to quantitatively reduce the double bond of the enone here, as you can see. So thank you for having followed this little presentation. But now, before we go to the Q&A session, I'd like you to show the setup in the laboratory. So please follow me.
Go.
Okay, I am now in front of the setup. So for those who have seen the webinar about the H2Pro, you can easily recognize the H2Pro here, and this is the gas module. I think that's the first time you can see it for real in a laboratory environment. So first, I'll go briefly through the description of the H2Pro, briefly because it's already the subject of our webinar. So for those who want more detail about it, please check it out. We will put the link into the video description. But please wait for the end of this one before watching this. So it starts with the pump, HPLC pump. Here, it always starts with the pump, as you have to create the flow through the line. So it aspirates the solvent here through a two-way valve here, which allows you to decide between the reactant and the washing solution. So it creates the flow and goes to a first pressure sensor that gives you the pressure at the beginning of the light here. Then it goes to a gas-liquid mixer here. It is either the hydrogen produced inside or the gas, like in that case. When you have connected the gas module, it's going to be the gas that will be injected at this point here, gas-liquid mixer. And then it goes to a bubble detector. This bubble detector gives you the ratio of gas over liquid. You can monitor it on the interface of the H2Pro. And then it goes to a first connection point here. This connection point allows you to, for example, bypass the heater here in case of, for example, let's say you want to do a reaction at 300 degrees. So you would need to put another heater, like the Phoenix flow reactor, for example. And so you can use this connection point to bypass this heater. So it goes to the Phoenix flow reactor and it comes back later here. So you can bypass this heater. But, so let's talk about this heater. So I can open it since it's not started yet, so it's not heating, and I can show you the inside. And here it is. So you can see here, there's a cartridge so the cat card 70 millimeter. So at this point of the line, you have, if you are working with gas, of course, you have your three phases. You have the solvent that is injected by the pump here, the gas by the gas module, and the solid catalyst that will remain inside the cartridges here. So three phases here. So closing it. And let's continue the description of the line. So it comes out from here and it goes to the second connection point I already told you about. And then it goes to a second pressure sensor here. So the difference between the two pressure sensors gives you the pressure drop you would experience in the cat cart. And then it goes to a back pressure regulator here, which creates the pressure through all the system, from the pump to this back pressure regulator. And then it goes to another two-way valve in the same way as the first one, but to either collect your product or just send the solution to waste. So here was the description of the H-cube. But now, let's say you want, instead of hydrogen produced inside, you'd like to play with other gases like carbon dioxide, monoxide, methane, ethane, and there's up to 13 gases pre-programmed. So you can do it quite easily by connecting the gas module, which is here. So now, the same way we went to through the liquid line, I'm going to go through the gas line here. So it starts with a cylinder. You cannot see it here as it is like outside the field of the camera, but you have to have a cylinder in order to connect it to the gas module and inject your gas. So you must have a reducer at your cylinder because the gas module can go up to 140 bars from the cylinder. And then your gas inside the gas module passes through the mass flow controller, which allows you to play between 0 and 100 milliliter per minute of flow rate, normal milliliter per minute. And then it comes out from the back of the gas module, and maybe you cannot really see it here, but there's stainless tubing in which the gas is going to the back of the H-cube probe, and then it's going to be mixed with your liquid, as I said at this point, the gas liquid mixer and the H-cube probe. So it's either the use of the hydrogen produced inside or the gas. So if you connect the gas module, then it disables the produce of the hydrogen inside. So there's two modes in this gas module. First, there's a standalone mode in which you can provide a flow rate to any flow setup, I would say. Not especially the H2 Pro, but any other flow setup you would have made. So for this, you would control the different parameters. So you would select the gas, you would put the pressure, you would set the pressure, and you would set the flow rate directly with those buttons here, with those three buttons to select the values and the parameters. But right now, if I'm pushing them, it does nothing, but you can see on the little screen, I hope, there's like the control mode. So that means it's connected to the H2 Pro because I connected it with a CAN cable that is passing behind. And this cable allows it to control only from the interface of the H-Pro. So you can here recognize the main tab for the settings of the H-Pro parameters, but first thing first, let's go and detect the gas module. It is in the external tab here, and first you have to click scan. And by clicking this button, it's going to scan every instruments, ThalesNano instruments that are connected to the H-Pro via a CAN cable. So it's not only the gas module, but it can be the Phoenix flow reactor, the card changer, and so on. But right now, only the gas module is connected. So it has detected the gas module, and there's a second tab that appears when you detect for the first time. So this is a tab that allows you to set up all the different parameters, but for the gas module only. For the H-Pro parameters, it's going to be in the main tab. I will show you in a bit. But first, let's set up the parameters for the gas module. So first, you have the gas selection, and which allows you to play with like 13 gases here. There's a list. So for us right now, it's just nitrogen. And then you have like different information. You can recognize the cylinder here. So you have the pressure that is detected in the cylinder. So don't forget to open the valve of the reducer at the cylinder, and it will show the pressure you delivered from the cylinder. So then you have to select the flow rates you'd like to inject into your flow line in the HQ. So it can be like in different units, but for us, let's keep it like milliliter per minute. So you can modify it, change the exact same way you would change the pressure, temperature on the main tab. Then you have indication of pressure inside the MFC, and here at the outlet. And right now you have your gas here, so it's not injecting yet because I didn't push start in the main tab. So you have here a little panel that tells you the different parameters you've set for the HQ. So see, it's pretty simple. So now we've set the parameters for the gas module. So let's go back into the main tab. There it is. And for those who have followed this webinar for the HQ Pro, I already went into detail of this. But yeah, here you can put the temperature of the heater, the pressure of your system, the flow rate here, and the different switch. You can see here there's a hydrogen which is disabled. It is because you have connected the gas module, so it's going to inject a gas instead of the hydrogen. You can either decide to inject one or the other. So when you've set all your parameters, let's say we have set up all of those, let's click Start. And then save reaction parameter. I don't save, but you have to know you can save them if you'd like to load them faster the next time. If you are repeating a reaction, for example, it's quicker. So now it's going to take a few minutes for everything to build up, for the temperature to reach, for the pressure, and for the pressure inside the gas module to build up as well, and to inject. And so when everything will be stabilized, you could then start your reaction by pressing, by changing the switch here from your solvent line to your reactant. So now it's time to answer your question. So please don't hesitate to send your question about this setup, about the gas module, or even the H2 Pro, and I would be happy to answer them right now. Maybe in the meantime, the first question comes up, so I can just go and describe you a bit of more tabs. So the tabs are pretty much the same as when you use the H2 Pro alone, but there's like just a couple of differences. So this is the main tab. So on the info tab, you have different informations, but actually half of them concerns the hydrogen. So here you are not using the hydrogen but the gas. So you can see like some values will be 0, but you can still see like, for example, the indication of the pressure, the temperature, even the valve opening, the gas-liquid ratio. And yeah, here your amount of H2, it's grayed out. It's grayed out because you cannot use it as you are using the H2 with the gas module, so the gas line is open and not the hydrogen line. So, important point here. So, you have to know, like, when you are using it in a standalone mode, I mean the H2, so you have the pressure hydrogen automatically set. But in our case, we have to change it to put the pressure at the outlet of the gas module if you want to monitor the pressure of the gas you delivered. And then you can follow the pressure. Then you have the event. Again, it's to follow the different status, different events, your H2 Pro and the gas module as well, because you have both that appears here. So you have the log tab, which allows you to load previous experiments, and the service, which is for, as it says, service purpose, and which allows you to follow the, if you have errors, for example. And then the external tab we already talked about. So, of course, if you want more details about all those different tabs, it is more detailed in the webinar just for the H2 Pro. But right now, I think I showed you all information that was important for controlling the H2 Pro with the gas module. So, that's all for the description of the setup. So, now let's go through the question. To register to our website, you can see them. And you can also see the previous video of the 5 previous webinars all along. So, is any other questions coming? I will wait for a couple of minutes if you have any more questions. Anyway, even after this webinar, feel free to ask your question directly to ThalesNano. So I can something I mentioned, and I can add, like you saw the setup, the gas module and the H-cube right now. But I mentioned you can also, and you saw some example of chemistry done on the Phoenix and gas module. So you can do the same way. If you are combining Phoenix with the gas module, only both of them, you would need a control module to, in order to manage both of them and to centralize the control of both of them. But you can also control directly from HQ Pro if you have like the three instruments, so a Phoenix, HQ Pro, and a gas module. You can combine, you can control all of them directly from the interface of the HQ Pro. So yes, the video, I repeat since you may not have heard, the video will be available afterwards to our website for those who registered directly on it. So please register, and you can also have access to all previous videos, all previous webinars. Another question is coming. So how many gas cylinder can be fitted to the module at once? So right now, the gas module allows only one cylinder at a time. So you can use this gas module with, as I said, like 14 different gases, but once at a time, at the moment. But we are also working in parallel to a gas module that could handle 2 cylinders, but it's not yet developed. So any other questions? So, and for those who could not see this webinar anyway, you could see directly on our website. Okay, so if you have any more questions, we will finish the webinar, and we will let you know for the next webinars that will be coming in the next weeks and months. So thank you very much for having watching. Thank you.